So bringing us home today is Ionic Rare Earths, ASX code IXR. The company is an emerging miner, refiner, and recycler of sustainable and traceable magnets and heavy rare earths needed to develop net zero carbon technologies. Presenting today is Managing Director, Tim Harrison. Tim, thank you for your time. Over to you.
Hi, Abby. Thanks for having us back. Yeah, good to be back and talking about a lot of the progress that the company's been making, specifically around the recycling opportunity through our 100% owned UK-based subsidiary, Ionic Technologies. Just our disclaimer. Ionic Technologies is at the forefront of recycling permanent magnets, extracting the magnet rare earths from the end-of-life materials and waste materials that are generated in the production of permanent magnets. Specifically, we extract the magnet rare earths to high purity oxides, which can then be redeployed in the production of brand new magnets. The process itself has been developed in the UK at Queen's University, Belfast. It's a hydrometallurgical process that is agnostic on magnet quality and composition. It can take magnets that are oxidized, coated, so it has a lot of flexibility. Beyond that, it can also take swarf, which is a byproduct or a waste product in the production of new magnets. As I mentioned, it's a hydrometallurgical process where we crush and grind the magnets, we digest the magnets to extract the rare earths and then separate them away from the base metals and the iron that also makes up the magnet alloy. We then separate the rare earths into the individual elements and then produce a high purity oxide. Talking through and you know, picture's worth 1,000 words. So the end of life magnets on the left there, we process those. We then extract the individual oxides, and then that material goes back into the supply chain to make new magnets that will empower the production of technologies that will go into net zero, but also quite importantly with a geopolitical theme, military and defence. As I mentioned, developed in the UK, the technology was developed at Queen's University, Belfast. They've got a leading research centre in ionic liquids, and we've taken the technology and the base IP, and we've continued to improve. We've just filed another 3 patents as we continue to position the technology to be robust for global expansion. From a geopolitical perspective, what we are seeing is a lot of support through policy, unlocking and looking to unlock new supplies of rare earths, specifically magnet rare earths. So one of the policies that's come into force earlier this year is the European Critical Raw Material Act. And importantly, that is setting a target of 25% of Europe's supply coming from recycling by the end of the decade. And if we think about the opportunity around just the consumption and demand for permanent magnets, the permanent magnet demand is expected to grow by about 60% between now and the end of the decade, driven primarily by the adoption and rollout of electric vehicles, but also the deployment of wind turbines in alternative low carbon options on energy generation. We have, through the course of the last 2.5 years since the acquisition of the technology and investing in taking the technology forward, we've enjoyed really good support from the UK government to date, and we announced some new grants earlier this week. The company has received approximately $5 million worth of grant contributions and commitments from the UK government. And they range from, you know, the initial program we received in September 2022, which was around funding the development of a demonstration plant. We've delivered that, and we've worked very closely with the Innovate UK and a number of other government stakeholders there. We last year received additional grants on the development of a feasibility study, which is nearing completion, and also in partnership with Ford and LCM, working on developing a UK domestic supply chain for magnet rare earths. Importantly, we are very, very close to our first production and delivery of those high purity separated oxides to LCM this month. and they will then be converted into metals, alloys. They'll go to a magnet partner and then ultimately end up back with Ford, who are developing electric drives in Halewood, at Halewood in the UK. And we expect that program will be completed next year. If we look at the new grants were announced earlier this week under the CLIMATES 2 program, which is an extension of what was announced last year. And on the back of the successes that we've been able to demonstrate through the previous grant funding, we've received another 2 grants. The important one here, I think, is the Revaluate program, where we're going to work with 2, industry partners, being Less Common Metals and Vacuum Schmelts, where VAC is going to provide us with 9 tonnes of pre-production or pre-consumer magnet scrap. So effectively that is swarf and offcuts from the production of magnets. We take that material, we convert it back to oxides, and then with those oxides, high purity separated oxides, they will then be converted to metals and alloys by Less Common Metals, who will then deliver those metals and alloys to VAC, which will then go into the production of brand new 100% recycled magnets for the UK and European supply chain and partners that we're working with there. The other program that we've received a grant for is Magnostic. It's a project where we're looking at new technologies that we have identified to look at advanced and alternative ways of demagnetizing magnets used in industry through the decommissioning process, and being able to then produce the demagnetized products that can then come back into our recycling supply chain. So they're 2 pretty exciting opportunities for us, and it was great to get additional support from the UK government this week. Our path to commercialisation. So where are we right now? Well, right now we've built and operated a demonstration plant where we're producing product and we're delivering that product to our supply chain partners. We're very, very close now on completion of the feasibility study. And that feasibility study will look at a 40-fold scale up on a commercial plant, which we're looking at building in Belfast. And that will effectively be a template on what we intend to evaluate through joint ventures and partnerships on a global rollout, specifically targeting key markets in Europe and North America. But we've also had significant interest from parts of Asia as well. Here is a photo of our heavy rare earth separation circuit, where we're separating dysprosium and terbium and taking that to high purity separated oxides. The technology has been advanced through a number of stages as we look to de-risk the technology and commercialisation. So technology readiness level is a way in which technologies are evaluated and they're on their path to commercialisation. And so where we consider the technology and our technical partners and we work through the financing of the project, we're at TRL 8 and we're 1 step away now from being a commercially proven technology, and that will be TRL 9, and we're anticipating that that'll happen in 2026. Our location in Belfast is a fantastic location for us to be commercialising the tech. Belfast is establishing itself as an offshore wind energy hub, and we have a number of partners in close proximity of where we're intending to build a commercial plant, smack bang in the middle of the Belfast harbour. As we complete the feasibility study, we've been working closely with UK-based engineering group WSP, and that engineering estimate is completed, and we're finalising the report now. We're also working on a life cycle analysis, which will again position the technology and the opportunity with an understanding of the carbon footprint of the products that we'll produce relative to conventional or existing supply of that material, which we think again will be another mechanism for the technology to be differentiated against the existing supply chain. We're working with local partners in the Belfast area on the approvals and application and planning permits. And we're also working with advisors on grant applications and funding opportunities through the UK government to help finance a portion of the project and set us on a path towards commercialisation. Beyond that, we've enjoyed extremely good support from the Advanced Propulsion Centre in the UK. And we're working closely also with the British Geological Survey on understanding what the availability of feedstock magnets looks like in the UK towards the end of this decade and beyond. We've received ongoing support through CLIMATES program through Innovate UK, and they've been a tremendous advocate of the company and what we've been doing in the market there. And finally, we enjoy a very good relationship with our local stakeholders, being the Belfast Harbour Estate and the Titanic Quarter Limited. And we're working on commercialisation of the plant in the Queen's Island area of the Belfast Harbour. As we finalise the commercialisation and the feasibility study, we're preparing all of our documentation, and this is a snapshot of a render of what we anticipate building in Belfast. And finally, just to talk about the joint venture that we've got with Viridis Mining and Minerals, we're looking at taking the technology that we've developed not only for magnet separation, but also for or magnet recycling, but also rare earth separation. And we're progressing a number of discussions with our partner in Viridis and also Brazilian stakeholders. And we'll have another delegation from Brazil visiting Belfast over coming weeks. So it's a pretty exciting time for the company as we look to commercialise the technology and be a producer of high purity separated oxides. So with that, Abby, thank you.
Thanks, Tim. Great presentation. So I do have a few questions for you if you have the time.
Sure.
Could you explain the significance of Ionic Technologies partnerships with LCM and VAC under the Revaluate project?
Yeah, look, Abby, it's a really important relationship for us because they're two groups that we've been working with for some time, both incumbent in the European supply chain and the ex-China supply chain. And so the relationship that we can now talk about publicly will enable us to work together to demonstrate what 100% recycled magnets potentially looks like for partners in Europe and the UK, as we can move some of those discussions towards deals in demonstrating what that supply chain looks like and the quality of that material. So again, it's a really important step in that progress towards an alternative supply chain.
Okay, Tim, so adding on to the supply chain in the UK and Europe, what's the significance of the Revaluate project in context of the rare earth supply chain in those countries?
Yeah, look, I think Revaluate sort of represents a mechanism for stakeholders and consumers in the European market to recognise that there is a mechanism there for that magnet supply chain to be developed in Europe. So through that partnership, we're demonstrating 100% recycled material, converted into metals and then ultimately magnets, but importantly, closing the loop on the waste materials that are produced in the production of magnets, coming back into the supply chain so that we can demonstrate a sustainable, secure path to production in the European market. So I think, again, it's a mechanism to demonstrate that this can be achieved. The technology exists, the partnerships exist, and we've got groups that are willing to work together to demonstrate that the market can be supplied from these alternative supply chains.
And Tim, what type of magnet scrap will VAC provide to Ionic Technologies and how will it be processed?
So the scrap that's being produced by vacuum smelts is effectively swarf. So this is offcuts that are generated in the production of magnets. When a magnet is produced, depending on the orientation geometry of the magnet, the magnet can be shaved, cut, and you can have waste volumes of anywhere from sort of 15 to up to 40% of what's actually the alloy going into being converted into a magnet. And so that waste material, that swarf, is a perfect feedstock for us. We've got a process that's agnostic. We can take all sorts of different variability on feed, but swarf is a great product for us, and we can take that back into our process and effectively minimise the wastage. And in theory and practice, take that material back into high purity oxides, which means that there isn't the waste that the industry probably has seen up until this point.
And how does the Magnostic collaboration aim to contribute to recycling and end of life permanent magnets?
Yeah, so the Magnostic program between ourselves, MPI and Swansea University is really looking at alternative technologies on the demagnetisation process. Now, what we do presently, we take the magnets, we put them in the oven, we take the temperature up to 400 degrees, and that removes the magnetism and makes the magnets a lot more user-friendly to handle. When you're looking at large arrays of magnets in a wind turbine, so the generator and wind turbine, that's a little bit more problematic. And so we've identified a number of technologies, and we're working with groups in the supply chain on looking at ways in which we can find a better way to do this. We've identified some technologies. Initial results have been really positive, and we're now at the next stage of taking the technology to a greater level of definition and demonstration, so that we can then move forward with potentially an alternative opportunity for the company to be more heavily involved directly in the decommissioning process, which then I think potentially has the opportunity for us to get access to this material much more readily. So I think this is potentially a big door opener for us in the decommissioning process.
And Tim, do you have plans to expand beyond the UK and Europe in the future?
Yeah, Abby, look, we've received a lot of interest. So obviously the UK opportunity and being in Northern Ireland means that we can participate in both UK and European markets through the Windsor framework. We've been looking at opportunities in Europe. We've been looking at opportunities in North America. We've got a couple of things that we're evaluating at the moment. We're also looking at some pretty exciting opportunities in Asia as well. So yeah, we do have a number of things that are bubbling away, and hopefully we're in a position where we can talk about them soon. But yeah, I think it's a pretty exciting position for the company, given we're armed now with the product. We know what our cost of production is. We know indicatively what our capital would look like in a UK market, how we think about taking that capital and replicating that in other markets, and the type of partners that we think we would work well with and have the opportunity to unlock a lot of value in our cost of production, but also working on the supply chain. So I think, the Western markets and the appetite is really moving, I think, with a lot of momentum on the recycling space, given it's a lower capital to develop, and we can immediately partner on the metal and magnet manufacturing to create these localized, insulated, secure, sovereign pods or networks of production that can be replicated in Western governments. So yeah, I think this is the part of the market that has the potential to move quite quickly.
Tim, thanks so much for your time. Fascinating presentation. We'll be keeping a close eye on the company, and I hope you have a lovely weekend.
Thank you, Abby.